Calculus is a branch of mathematics involving or leading to calculations dealing with continuously varying or changing functions. The concept of calculus was developed by Isaac Newton and Gottfried Leibniz. Isaac Newton was said to have been outraged when in 1684 Leibniz published his works on calculus. Newton claimed to have worked on the concept of calculus earlier, but he never published his works. Today, Isaac Newton and Gottfried Leibniz are credited for independently discovering and developing the concept of calculus. Calculus can be divided into two parts as differential calculus or differentiation and integral calculus, also known as integration. Calculus can be applied across different fields from science to engineering to economics. It could be seen in calculations involving velocity, acceleration, rates of change, maxima and minima, or maximum and minimum values. When we defined calculus, we said calculus is a branch of mathematics involving or leading to calculations dealing with continuously varying or changing functions. The question is, what are functions? A function is an expression that defines a relationship between one variable and another variable, namely a dependent variable and an independent variable. Looking at an example of an expression or equation, we have y is equal to 4x squared minus 2x plus 2. When x is equal to 0, y is equal to 4 into 0 squared minus 2 into 0 plus 2. That is, y is equal to 0 minus 0 plus 2. Y is equal to 2. When x is equal to 1, y is equal to 4 into 1 squared minus 2 into 1 plus 2. That is 4 minus 2 plus 2, which is equal to 4. It is clear from this that y is dependent on x. So it is said to be the dependent variable and x is independent. That is, it is the independent variable. That said, y is a function of x, or y is equal to function of x, which mathematically could be written as y is equal to f of x. And if that is true, if y is equal to f of x, this could then be written as f of x is equal to 4x squared minus 2x plus 2. And that is referred to as the functional notation. And if x, is equal to 0, the functional notation is f of 0 is equal to 4 into 0 squared minus 2 into 0 plus 2, which is equal to 2. And if x is equal to 1, the functional notation is rewritten as f of 1 is equal to 4 into 1 squared minus 2 into 1 plus 2, which is equal to 4. Now that we have a basic understanding of the functional notation, let's look at some simple problems under functional notations. F of x is equal to 5x squared minus 2x plus 1. We're asked to find f of 0, f of 4, f of negative 2, f of 3 minus f of 1. F of 0 is equal to 5 into 0 squared minus 2 into 0 plus 2, which is given as 0 minus 0 plus 2, which is equal to 2. F of 4 is equal to 5 into 4 squared minus 2 into 4 plus 2, which is equal to 5 into 16 minus 8 plus 2, which is simply 80 minus 6, which is 74. F of negative 2 is equal to 5 into negative 2 squared minus 2 into negative 2 plus 2, which is equal to 20 plus 4 plus 2, which is equal to 26. Now, f of 3 minus f of 1. To find that, we need to find f of 3 and f of 1 distinctly. F of 3 is equal to 5 into 3 squared minus 2 into 3 plus 2, which is equal to 5 into 9 minus 6 plus 2, which is 45 minus 4, which is 41. F of negative 1 is equal to 5 into negative 1 all squared minus 2 into negative 1 plus 2, which gives 5 plus 2 plus 2, which is equal to 9. That is, f of 3 is equal to 41 and f of negative 1 is 9. Therefore, f of 3 minus f of negative 1 is equal to 41 minus 9, which is equal to 32. That's it for this problem. Let's look at the next problem. F of x is equal to 2x squared plus 3x minus 7. We're asked to find f of 2 divided by f of 1 in part A. F of 2 is equal to 2 into 2 squared plus 3 into 2 minus 7, which is 8 plus 6 minus 7, which is simply 7. F of 1 is equal to 2 into 1 squared plus 3 into 1 minus 7, which is 2 plus 3 minus 7, which is negative 2. That is, f of 2 divided by f of 1 is equal to 7 divided by negative 2, which is equal to negative 7 over 2, or in decimal form, negative 3.5. In part B, we're asked to find f of 3 plus b minus f of 3 over b. Defining each function uniquely, f of 3 plus b is equal to 2 into 3 plus b all squared plus 3 into 3 plus b minus 7, which is equal to 2 into 9 plus 6b plus b squared plus 9 plus 3b minus 7, which is equal to 18 plus 12b plus 2b squared plus 9 plus 3b minus 7. Now 18 plus 9 minus 7 is equal to 20 plus 12b and 3b are equal to 15b, and we have 2b squared left. So this is the value of f of 3 plus b. Let's create more space for f of 3. Now, we know f of 3 plus b is equal to 20 plus 15b plus 2b squared. Now, f of 3 is equal to 2 into 3 squared plus 3 into 3 minus 7, which is equal to 18 plus 9 minus 7, which is equal to 20. Now, f of 3 plus b minus f of 3, which is the numerator of this expression we have here, is equal to this, which is 20 plus 15b plus 2b squared minus f of 3, which is this 20. That is 20 cancels 20, which is equal to 15b plus 2b squared. Therefore, f of 3 plus b minus f of 3 over b is equal to 15b plus 2b squared, which is what we have here, over b, which is 15 plus 2b. So this is the final answer of this problem. And that's it for the introduction to calculus and the functional notations. If you found this video helpful, kindly give it a like and subscribe to this channel. See you in the next video.